Hey, my name is Lukas, and in this video we're going to take a look at how you can run Payload CMS inside Docker and how you can deploy this setup in the cloud. I'm right here on the Payload CMS website, and I will grab this npx create payload app command from the website. I will copy it, and then I move into my code editor and I will paste it in the terminal and hit enter in order to start the installation wizard. It's going to ask me to install the following package, and then it will guide me through this installation wizard. I will give my project a name and call this one payload demo. I will use a blank template and use MongoDB as my database. We don't have a database running right now, so we do need to run with the default connection string right here. And now it's installing all of the necessary dependencies, and it will finish the installation setup. As you can see right here on the left side, a folder was created named payload demo, and we have all kinds of different files and folders inside here. All right, now that payload is installed, we want to spin up a MongoDB database, and we will use Docker for that. And I will create a new terminal right here. And in the terminal, I write Docker run Mongo. And this command will fetch the official MongoDB Docker image from Docker Hub. And you can go to hub.docker.com, for example. And in the search bar over here, look for MongoDB. And then you will find a list of all of the available public images on Docker Hub that you can use using the Docker run command. And if I filter this and only show the official Docker image, we can see this one right here, Mongo, and this is the one that we are going to be using. And if I click on tags right there, you can find a list of all of the different versions that are available for MongoDB. And if we scroll down a little bit further, we will be using 8.0.12 for this tutorial. So I will copy the tag and I will write colon 8.0.12. Now this is a very basic Docker command that will spin up an instance of MongoDB. But there's a few things that we will do to modify this command. After the run, after Docker run, I will write a -- name, and let's start with giving this a name and call this one payload Mongo. Next up, I will map port 27017 of our host machine to 27017 of the Docker container. So you can think of this: if the MongoDB container spins up, it is listening on port 20017, but this port is not available on our host machine. And we need to map this port through the container to be able to access MongoDB on our host machine. And the last thing that we are going to do is I will attach a volume, call this one payload data, and I will map it to, I think data/db is the correct directory, but we can quickly look this up on Docker Hub because you can find all of the necessary documentation over here as well. And if I search for the keyword volume on this page and scroll down a little bit, you can see the setup with a volume, and it mounts to /data/db. All right, so let's run the command and see if our database is starting. And one more thing that we could do is add this -d, and this means run it in the background. But I tried it and I get an error right here, cannot connect to the Docker daemon. And that's because Docker Desktop is not running on my machine. And if you run into an issue similar to that, you need to make sure to go to docker.com, check out the products Docker Desktop, and then download Docker Desktop for your operating system and install it on your machine. I already installed it, but I don't have it running right here. So let's quickly search for Docker and launch Docker Desktop. Now I don't care about the UI right here. I just want to make sure it is running, and now I try to execute the command again. As you can see, I type in docker ps to list out all of the containers that are running, and we can see our payload Mongo container that we just spun up, and it's using the Mongo base image version 8.0.12. It maps port 27017 to 27017 inside of the container, and we attached a volume to it. So this is great, and we can see if we can get our application running. So I will quickly check in the .env file. We are connecting to localhost, and by default, the database connection URI, like the syntax is usually username, password, host, host port. But if you don't supply all of these settings, like we didn't set a username, we didn't set a password for our MongoDB instance right here, and so it's simply using an empty or the default user and no password, and we are connecting to 270.17. Okay, so let's quickly launch our payload application. I will cd into the payload demo directory, and then I run pnpm dev in order to start a development server of payload. And as you can see, port 3000 is in use by an unknown process using available port 3001 instead. I have something else running on my machine on localhost 3000, so let's check if we can reach payload on localhost 3001. There we go. We can see the welcome screen and it's looking good. So next step, we will try to get payload running inside Docker. So I will exit the development server right here, clear the output from the terminal, and then we will try to put everything into a Docker container. And as you can see right here on the left side, there is a Docker file that comes with this payload installation. But when I try to run this Docker file or try to build it, I ran into several issues and it didn't work for me right out of the box. And actually I wrote a whole blog post about this, which goes step by step through the issues that I encountered when trying to build this Docker files and the steps that I took in order to avoid the issues. And at the end of it all, I created this Docker file that you can use. You can just copy it from right here, which we are going to do. I will copy the Docker file and I will paste it in right here. But before we are going to use this right here, we do need to make sure that our node and pnpm version matches. And if I type node-v in the terminal, I can see I'm on version 22.14.0. And right here, we're using 22.12.0. And we do want to make sure that our node version that we use to install payload right here matches the node version inside of the Docker file, because otherwise we could run into dependency conflicts. And the same is for pnpm. So I will type pnpm-v and we can see I'm on 10.12.3, but right here we are using 9.13.2. So let's look for all of the instances of 9.13.2 and I will replace it with 10.12.3. All right, so let's try to build this and see what happens. I will run docker build. I will tag this image payload and I will write a dot to reference the current directory. So the build is going to take a few minutes, so let's quickly wait for that to finish. So after a while, the build did not finish correctly. And if we scroll down through these logs right here, we can see an error message and it says incompatible React versions. The React and React DOM packages must have the exact same version. Instead, React is at version 19.1.0 and React DOM is at 19.1.1. And if we take a look at the package and look for the React package right here, we can see React is at 19.1.0. So what we can try to do is simply bump this version and see if that resolves any issues. And what we want to do now is run pnpm install again in order to fetch the updated dependencies. And this is going to take a few seconds, and you can see right here, we removed 19.1.0 and we added 19.1.1. And whenever you make such dependency upgrades, you want to be very careful and double check that everything is working after that. Because when we installed everything, Payload is actually, they choose all of these dependencies on purpose because they don't want to run into any issues. And if we manually modify that, we can run into other dependency conflicts. So you want to be very careful when doing something like this, and you want to always double check if your application is working after a dependency upgrade like this. And actually, we need to do a few more things. If we go back to the tutorial that I just referenced earlier, there are a few little tweaks that we have to apply in order to get this running. And first of all, we need to configure next for standalone output. And this is done by just copying this little line, output : standalone. Then I go back into my project, open my next config, and I will paste this right here at the top of the file, at like inside of this configuration object right here, output standalone. Second thing that we need to do is set up a public folder, because right here in the Docker file, if I look for public, we are expecting a public folder. And you can see right here in the comment, remove this if you don't have this folder. So you could either remove this line, or we could create a new folder in our project, name this one public. And since it is empty now, I will add a git keep file to this. So create a new file in the folder .git keep, and this will make sure that the folder will be included in the repository even though there's no content inside. So if we scroll to the end of this connection string, we can see I'm using this auth source admin. So let's copy that, go back to our env and paste it in here. Now we didn't have any trouble connecting to the database in the test that we did earlier. There will be a problem if we are using a database user and password. So it's just a good practice to include this auth source admin if you're authenticating against your database with credentials. And the last thing that we had to fix is file upload permissions. And this is already fixed in the Docker file. If you copied the Docker file from the blog article, this line is already included in the Docker file. So with all of these changes, let's quickly go back and see if we can build the Docker image again. So the Docker build went through and we didn't get any errors. So this is looking good, and it took surprisingly long to build this Docker image. So let's see if we can run Payload inside of this Docker image that we just built and connect to our database. And before we can do that, we need to create a Docker network, and I will write Docker network. I think the command is create. I don't remember it. If you don't remember the command, you can simply write Docker and then the command and hit enter in order to get a little guide, and it's called Docker network create. So let's write Docker network create, and then we will give it a name and name this one Payload network. I will hit enter. The network has been created. And this is used to connect our payload container to our MongoDB container so that they can communicate through their own little private network. And once we did that, I will simply type docker ps again. And we can see our running MongoDB container. And what we want to do is I will grab this name right here. And this name also acts as the host name that we can use inside of this private network in order to connect these two containers and in order for them to communicate internally. So in my env file, I will replace the 127.0.0.1 and I will paste in the container name of our running MongoDB container. So now database URI is set. I will save my environment variables file. And then we can spin up a container from the payload image that we just created. So I will write docker run, then -- env file in order to load this env file as environment variables, and it's .env. And then we use a name for the container. -- name will be payload, and the image name of our Docker image, it was payload as well. So let's see if this works already, and we can also add a -- network right here in this docker run command and reference the payload -network. I will write -d in order to run this in the background, and then I hit enter in order to spin up the container. Okay, of course we forgot something. We wanna expose the port 3000. So let's quickly stop this container, stop payload, and I will remove it, docker remove rm payload in order to remove the container. And then we will run the command again, but this time we also add this -p in order to map the port 3001 on our host machine to 3000 inside of this container. I will hit enter in order to spin up the container again. And we also need to docker network connect. And then we write the network name, payload network, and our payload Mongo, because this MongoDB container also needs to be inside of the same network. Let's hope we didn't forget anything. And if we go to localhost 3001, we can see we are connected to our payload instance that is now running inside of this Docker container. Both containers are communicating via their own private Docker network, which is called payload network. And we are persisting data of this payload Mongo container in a volume. Great. So how can we deploy all of this to the cloud? Because you don't want to run your backend on your local machine. You want to have it somewhere in the internet so that you can access it from 24/7 and from wherever you are. So let's commit all of these changes to the repository. When we ran the install wizard, there was a repository created automatically for us. And I will say feature get payload running in Docker, for example, or whatever you want. And then I will go over to GitHub and save all of these changes in a repository. I will click new, create a new repository, name this one payload. Payload is available, create repository. You can make it private if you want. And if we scroll down a little bit further, we can copy this command right here, or these 3 commands, in order to upload all of the contents to this GitHub repository. If we go back to GitHub, if I refresh the page, you can see the content is now here. And then I go over to Sliplane.io, and Sliplane is a hosting provider that makes it very easy to deploy these kind of Docker setups, and it's perfect for our little use case. So I will click on Get Started with GitHub. Then inside of the dashboard, first thing that I'm going to do is I create a new project, call this one payload. Inside of the project, I will deploy a new service, and then we have to create a new server. I will run with the default server right here, and I will name this one payload as well. So click on create paid server. You can choose a different location, and we can upgrade the server at any time if we need more computing power. So I will select the server. And then right here, we have these pre-configured images. And as you can see, there's also a MongoDB preset. So let's start with deploying our MongoDB database first. We were using 8.0.12. I don't want to make this public because I only want our containers to communicate through the internal network. And if we scroll down a little bit, you can see this time we're configuring the MongoDB database with a username and also a password. So we need these connection settings later, but for now, let's just give it a name, call this one payload Mongo right here, and then I hit deploy in order to deploy this MongoDB database on the server that we just created. So this is going to take a few seconds only, probably. And if we click on the service, we can see what is going on. We can see the config that we just set when we created the service. And we also get some more information like the internal host name, for example, that we will use when we deploy our second container in order to connect to this database. You can also check out the logs, and now it's pulling the image and it is installing everything. So the image has been downloaded. So it's probably only going to take a few more seconds for the deploy to come live. I will go back into the project folder. The deploy has become live, and I will click deploy service again. Then I select the same server where our MongoDB database is running on. I will click on repository, and then I need to configure repository access because we just created this repository on GitHub, but we do need to grant Sliplane access to this repository so that we can download the content and deploy it. So I will click on my GitHub account. I will sign in with my GitHub account. If we scroll down a little bit further, there is this select repositories dropdown. And if I search for payload in here, we can find the repository that we just created. I will click on save. And then I will be redirected to Sliplane. And now in the dropdown, if I look for payload, if I click on refresh list, we can see the repository is now showing up in the list, and I can select this repository and scroll down a little bit further. So for the environment variables, if we go back to our env file, what I can do is I can just copy this env file and I will paste it in right here as the environment variables. But one thing that you will notice, the database URI is not correct now. So I will open up a new tab, go to Sliplane again, select the project, and then select the database service. And right here, first thing that we are going to copy is this internal host. So I will copy the internal host right here. I will go back to the payload service that we are just about to deploy. And then I will edit this database URI environment variable. Then I will select the internal host name that we set previously, and I will replace it with the internal host name that we are supplied by Sliplane. And if we scroll down a little bit further, we can see this time we are using the root password and root username. Root username is admin, and I will copy the password. And then the format is as following: admin : password at internal host name port database name. So I will click on apply, and service name will be payload, and then I hit deploy in order to deploy this service. So let's quickly wait for that to finish. So the application has been deployed, and if I click on this little link right here, I will be redirected to my payload instance. As you can see, we are hooked up with this domain and it's running under HTTPS. I can go to the admin panel and go through the installation wizard right here, set up a first user, and now I am in my payload dashboard. I can upload media and do whatever I want. Maybe one more thing before I will end this tutorial. You can upload media right here. By default, I think it's uploaded into a directory which is called media, but we are not persisting this data. If you want to persist this data, you need to attach a new volume. I will click on add new, and I say payload media folder. And I think the directory is /app/media. Then I click on attach volume, and this will trigger a new deploy in the background. The deploy is in progress because we attached this volume, and this can be used to persist data. But keep in mind, you are now uploading and downloading files onto the server that we just created, which is fine if you're working with smaller apps, but at some point you probably want to look at some object storage solution for your media files if you're working with a lot of them and if you have significant traffic. So I want to end this tutorial at this point. If you did like the video, give it a thumbs up, comment, like, and subscribe, and I see you next time.